the first chapter, that is matter in our surroundings. Matter in our surroundings. So this is the first chapter of 9th standard science, where we'll be dealing with what exactly matter is, its physical nature, the properties of matter, the various states of matter, and the state transformations of matter, and many more topics. So let's proceed. The first question that arises by seeing this chapter is what exactly matter is. So if anyone has any answer that what exactly matter is, please raise your hands. I will unmute you and you can tell me what exactly is it, or you can send your answers through chat also. So if anyone has, so if anyone knows the answer, please raise hand and I'll unmute you. What matter is? Okay, so I see a hand raised.
Answer.
Yes, Anuj, please answer.
Everything present in our surrounding, which क्या जो सर जगह घेरती है
Okay,
तो मैं उसको मैटर कहते हैं.
okay.
Everything particle present.
Okay, I understand. I understand.
और तो साइंस की बुक ना होगी की वो पहले चैप्टर कौन सा मैटर इन
Okay, so you were right. You're partially right. So we'll look into the definition of what exactly matter is, and to give you an idea, matter, anything. Please turn off your microphones. Please keep them in mute mode, or else it will be a disturbance for others. So matter is anything which occupies space and has mass. Okay, so I hope you all understand that matter is anything in our surrounding that occupies space and has mass. Okay, so anything like water, so anything like water, sand, clouds, air. Okay, so anything which occupies space and has some mass is termed as matter. Okay, so I hope it is clear to you. If you have any questions, you can raise your hands. I'll unmute you. You can ask me the questions, or you can also send a question through the chats and I'll look to your question and then we can proceed. So now the question rises that what are the constituents of matter? What exactly is matter made up of? So to answer this question, we'll see. So according to the early Indian philosophers, every living and non-living thing, it is made up of 5. Okay, please don't switch on your, please don't unmute yourself. Please keep your mics muted or else it will be a disturbance for others. Okay, if you have any queries, please raise your hand. I will unmute you and then you can ask your query. Okay, so now, as I told you, according to early Indian philosophers, every living and non-living thing is made up of 5 basic elements called Panch Tattva. Okay, so this is a philosophy by the early Indian philosophers which believed matter was made up of Panch Tattva. They were air, water, earth, sky, and fire. So according to the early Indian philosophers, these were the five things which constitute which together formed matter. This was this was the philosophy of the early Indian philosophers. Now, when we look into this in a scientific way, we will see what exactly a matter is, what are its constituents. So, if you don't have any doubts, I'll clear the board and I'll move further. Okay, so if you have any doubts, you please raise your hands and I'll tell you. I'll unmute you and I'll clear anything that is confusing you. Okay, so now as I see no hands raised, we'll move ahead. So to give you an idea, let's consider this block.
Done speaking.
Please mute your mics. Yes. So let's consider this. Now we'll take one small part and we'll see it in a magnified manner. Okay, this is our matter. Now when we see the microscopic view of the matter, we see there are small particles which are arranged in a particular manner in the matter. Okay, in this manner, this whole thing was filled. So this is what exactly a matter is constituted, made up of. So matter is particulate in nature. By seeing this, we can conclude that matter is particulate. Matter is particulate in nature. Now, by this sentence, we mean that matter consists of particles. Okay, so this is the sentence which basically means that matter consists of particles, which is clearly visible in this image. Now, for example, we can learn this through an example also. Now, this answers the question, that is matter continuous? Is matter continuous or particulate? Okay, this is the question that is always asked, that is matter continuous or particulate. So matter is particulate in nature. Okay, now to explain it to you with an example, we'll see an activity. Okay, so we'll see an example over here where we'll put a drop of red color in water. Now the color of water will also turn red. Now this happens because the particles of red color mix with the particles of water. Now see, we have one beaker. Now see, we have four beakers, suppose. Now these are our four beakers. In first beaker, we have filled water and we put red color into the water. So the water becomes red in color. Okay. Now as we move ahead, what we will do is we will transfer 10 ml of this water into the other beaker. Now when we transfer this into the other beaker filled with water, we'll see that in this beaker the color red becomes slightly light than that in the previous beaker. Now as we move ahead, we'll again transfer another 10 ml from this beaker to the next beaker. So in this also we'll observe that again the intensity of the color has decreased. So more light. So the red color becomes more lighter. Now as we transfer for 10 ml from this beaker to the next beaker, we will see that eventually with the transferring, the color has changed to, like, the color has become very light. So by this we can see the size of the particles is actually very small. What happens is the red color particles of the red color, they mix along with the particles of water. Okay, so basically it shows that the particles are very small and they mix in the spaces between. So they can be broken into further particles. As for example, we'll see on dilution of color solutions, as we see in the figure, we can still see the colors. This means that there are millions of particles present in the color. Now suppose we added red color in this beaker of water. As we transferred it further, we see that the red color still exists. So it shows that the red color had millions of particles, and every time we transfer, we try to reduce the intensity, we are getting red color. So it shows that there are various small particles, and that particles are very small, and they just divide themselves onto dilution. So this is the basic idea, which shows that particle matter is particulate in nature. Now by particulate in nature, we mean that matter is made up of particles. And to see the size of the particles, we can conclude by this activity that particles are very small. Okay, and they together form matter. So if you have any queries regarding this, you can ask me, or else we'll move ahead. If you have any queries, you can raise your hand. I will unmute you, or you can send me the question through chat and I'll answer. Okay, seeing no questions and no hands raised, I think I'll move ahead. Now, I have a small question for you all, and you guys need to tell me what I told you. The definition of matter, that anything which occupies space and has mass is matter. So I'm writing a few substances, a few things, and you need to tell me what is matter and what is not. Okay, so here they are. First one is happiness, then air, sandwich, thoughts, juice, and eraser. Now wait just a minute. eraser, then table, smell of perfume. Now you guys tell me what all are matter. So anyone who knows the answer, you can raise your hand. I will unmute you, or you can send me your answer through chat. Okay, I'm waiting for your answers. You have 30 seconds, so you can send me the answers. Or if you have the answer, you can raise hand and I'll unmute you. Okay, please raise your hand if you have the answer. I'll unmute you and you can answer. Okay, I have one hand raised. Yes.
Air,
Yeah.
sandwich,
Yes.
juice,
Yes.
eraser,
Yes.
and table.
Okay, good. You're correct. So, and why are all these, why are you considering all these as matter?
Because all occupy space and has matter and has mass.
Okay, great. Okay, that's absolutely correct. Uh, Good for everyone. She gave the correct explanation. That is, everything which she mentioned has occupies space and has mass. Okay, so the ones which I have underlined, these are matter. Okay, so now we'll move ahead and see a few characteristics of these particles that form matter. So what we'll see now is the characteristics of particles of matter. Okay, so we all know that matter is made up of particles. So now we need to see what are the characteristics of these particles that form matter. Okay, now seeing the characteristics, we'll first now the going moving on to the first, we have that particles of matter have spaces between them. Okay, so the first characteristic is particles of matter have spaces between them. This is an important thing to remember. So you all must note this. So as we saw the example earlier where we saw the magnified view, the magnified view of the matter was something like this where the particles were arranged in this manner. Okay, so it is clear from here. You can clearly see that there are spaces between these particles. Okay, so it is important to remember that the particles of matter have spaces between them. Now we move on to the second characteristic, that is particles of matter are moving all the time. Particles of matter are moving all the time. Okay, so by this we mean that the particles that are present in matter, they are in motion all the time. Now you must be knowing that anything which has motion sorry, anything which has motion has kinetic energy. Okay, so in this manner we come to know that particles of matter possess kinetic energy. Which energy? So to let you know, particle this shows that they have kinetic energy. So this is the energy which comes by virtue of motion. Now the third characteristic that we'll be discussing, the third characteristic is that particles of matter attract each other. Particles of matter attract each other. Okay, so as you see that a matter has a definite shape. So forces of attraction, a solid in a solid has the highest forces of attraction. So which mean these forces of attractions is actually between the particles that are present in matter. The particles that are present, they have a force of attraction between them which holds our matter together. Okay, so these are the basic properties of particles of matter. You can note these down, or you can also find all the notes on S2S app. So you can go through the notes from there, and you can, if you have any doubts, we can discuss those doubts. So these are the basic characteristics of matter. So now I'll wait for a minute for you guys. If you have any questions or doubts regarding the same, you can raise your hands, or you can ask me the doubt through chat and I'll answer your queries. Okay. So I'll wait for a minute. Please go through the points. I hope there are no doubts that you are facing. Seeing no hands raised and there are no questions through chats also, I think we should move ahead. Okay, so after this, we'll see each of these characteristics in detail. Okay, please keep your mics. Please keep your mics in mute mode. Now, first characteristic, that was matter, particles of matter have spaces between them. Okay, so this is the first point. The first characteristic that we saw, that particles of matter have spaces between them. Now, have you now we will discuss this. I'll give you an example and explain this to you. Now whenever we mix anything, for example, we'll take sugar and water. Now we mix sugar and water. Now have you ever wondered that what causes the sugar to get dissolved in water? So what happens is, uh, this happens because water has spaces between, the water particles have spaces between them. So when we mix it, the sugar moves into the spaces between the particles of water, and then this mixture is formed. So show you I'll show you what happens at the microscopic level. Now what happens is, We'll see this in 3 phases. So this is our first, this will be our first phase, this will be the second phase, and this will be the third phase. Okay, so in the first phase we have water. So these are the particles of water that are present. So it has numerous millions of particles. So we will draw a few particles over here, and now clearly we know there is space that the particles have space between them. So this is what is present in the beaker in the microscopic level. Now what happens is we have our water, the particles are there, and what we do is we add sugar to it. So while adding sugar, this I'll show you in red color. Now we are adding sugar to it. Now the sugar particles are falling into water and they are getting deposited at the bottom for now when we have not mixed it. Okay, so we are adding sugar to the water. Now we'll move towards the next step, towards the stage 3, where we have water all around in the beaker. These are the particles of water. Okay, so now what we'll do is we'll use a mixing rod to mix all the sugar. So after mixing, what we find is that the whole water has become sweet. So this happens because the sugar that was deposited at the bottom, it takes places in between the particles of water. So all this gets mixed and forms a mixture. So this experiment clearly shows that there is space between the particles of matter, and when we mix two substances, the particles of one get settled in the spaces between the particles of other, as it is clearly shown in our stage 3. Okay, so this is how we proceed. This shows that how the particles of sugar take place in between the particles of water and form the mixture. I hope this is clear to you all. If you have any doubts, you can raise your hands or you can send me your doubts through chat. I'll wait for 30 seconds. Okay, I see there are no hands being raised. Everyone was able to understand this. So we'll move ahead and move on to the second property, that is, now the second property that we'll be discussing is particles of matter are continuously moving. So the second property, particles of matter are continuously moving. Okay, so this is our second property, which is particles of matter are continuously moving. Now, as I told you, suppose we have a container, or suppose this is our matter. Okay, we have particles in it. So we have particles. Different particles are present in this matter. There are millions of particles, but we'll be seeing a few of them. So what happens is all these particles are in random motion. So maybe one will be moving once towards one direction, other will be. So all these particles are always in motion. Okay. So this is what our second characteristic tells. Now by this there are a few points that we come to know. The first one being as please mute yourselves. Now the first one being as the particles are always in motion, therefore they possess kinetic energy. This we discussed above. Okay, so this is the first point that we conclude. This is the first point that we conclude. Now moving on to the second point. Now I already told you kinetic energy is energy which comes by the virtue of motion. Okay, so any body which is in motion has kinetic energy. Okay, so the particles of matter intermix on their own with other particles of matter. So those particles which have high kinetic energy or are in motion, they intermix. Sorry, they intermix on their own. Those particles which have high kinetic energy, which possess kinetic energy, they intermix on their own. Okay, so by discussing this point, there's another phenomena which we need to focus upon, that is diffusion. Okay, so by diffusion, when we go with the definition, it is the process of mixing of two different types of particles together. Okay, now suppose we have two types of particles, two types of matter. So these are the particles of these are the first type of particles, and these are the second type of particles. So this is something before diffusion. Now when diffusion occurs, what happens is, okay, suppose let these be the particles of one. So clearly these particles of both the matters have mixed, and this process is diffusion. So what exactly diffusion is, I'll give you the definition. The process of mixing two different types of particles together is called diffusion. Okay, so now I told you that these particles intermix together if they have kinetic energy. Now when we talk about kinetic energy, these now we need to know one thing, that is kinetic energy increases with heating. Okay, so if any body is hot, it will have higher kinetic energy as compared to a cold body, a cold particle. Okay, so if we heat this system, if we heat, then you will notice that diffusion is faster. Okay, so this is one point that we need to keep in mind. So if you have any doubts regarding this, regarding the second property, you can raise your hands or you can ask your doubts through chat. I'll answer and then we'll proceed further. Okay, so I'll wait for you. If you can read all this. If you have any doubts, you can ask me, or else we'll move ahead. Okay, as I see there are no hands raised, so everyone has understood everything, I feel. Okay, everyone, please switch off your videos. Okay, now we'll move ahead with our next property. Our third property was particles of matter attract each other. Okay, so the third property.
They are using the computer audio.
Okay, now the third property, that is particles of matter attract each other. So this is our third property that we had studied, and we'll discuss this in detail. Now there are a few points under this. I'll discuss with you first, and then I'll write those down. Okay, so the particles of matter are always held together because there is a force of attraction between them. Now, I told you that the particles, they, if we consider any matter, it is held together. So the particles of matter have some force of attraction between them, and on the basis of which it is further classified. So we'll see that later. And the amount of this force, the particles, it varies in different forms. Okay, so the solids have the highest force of attraction, and the liquids have slightly less force of attraction, and the gases have the least force of attraction within them. Okay, now to show you, let us consider this as a solid, this as a liquid, and this as gas. Now if we see the particles in solids, the particles are closely packed. Okay, whereas in liquids they are loosely packed. And when we come to gases, okay, so these are our solids, liquids, and gases. Okay, so it is clear. that solids have the highest force, okay, and the liquids have slightly less, whereas the gases have the least force of attraction. Okay, I hope you all understood this concept. Okay, so I'll tell you an example and you can understand this in a better way. So now whenever you move your hands, you can easily move your hands through air. So this is because there's a lot of gap between the particles of a gas, that is air, so you can easily move your hands. Now when you put your hand inside a tub of water, it is slightly difficult to move your hand. This is because there is less space or less force of attraction between the particles. Now when it comes to a solid like a wooden plank or a brick, it is not possible for you to break or move your hand through it. You need special skills to do that, okay? And don't try. So this gives us the idea that gas have least force of attraction, followed by liquids. This is followed by solids. Okay. So if you have any doubts regarding the same, please ask me. Please raise your hands. I'll discuss this. I'll discuss your doubts and we'll move ahead after that. Okay. So I'll wait for you. Okay. I'm seeing no doubts through chat or no hands raised. So I feel I should move ahead. Everyone has understood. So after this, we will see the states of matter. Please please keep your microphones in the mute mode. Now we have states of matter that we'll be discussing. Okay. So what exactly, how do we define states of matter? So now we know that particles of matter have forces of attraction between them. Now based on this, based on the amount of force of attraction they have, okay, so this is based on amount of force of attraction. Okay, so on the basis of this, our stage, there are three states of matter. Okay, so the three states of matter you all must be knowing are solid, liquid, and gas. Okay, so now we will see basics of these states of matter. Okay, so now we have the solids, liquids, and gases. So let's start with solids. Solids, these have a specific shape, and have distinct boundaries. Both the point 1 and point 2, they are almost the same, and the third one is that they have own volume. Now, as we see a solid and we see the arrangement of particles in it, we see this kind of arrangement. Okay, particles are closely packed with each other. So therefore, these have very less motion. Least motion. As the motion is least, therefore kinetic energy will be least in solids. Okay. Moreover, as the particles are closely packed, they can't be compressed. Now by compressing we mean to bring the particles closer to each other. Okay, and therefore solids have highest attraction, highest force. Now we all know the examples of solids. We have our table, our almirah. These all are examples of solid. Okay. Now I'll just ask a question, and I want an answer from you guys. Now we have a rubber band. Okay. Now consider a rubber band or a sponge or salt. Are these substances solid? Anyone who knows the answer, you can raise your hand. Or yeah, I have an answer. Yes. Are solids, are sponges or rubber bands solids?
Yes, they are solids.
How?
Because the molecules present in them are closely packed.
Okay, yes. And
And
when
they
we,
have a definite boundary. They
yeah,
have
and
a definite shape.
yeah. But when we see sponges, we can change their shapes.
Yeah.
Yeah, so I'll tell you that substances like when you consider salt also or rubber band or sponge, they all have a definite shape when we see in a smaller level. Okay, so all these are solids. You are absolutely correct. Okay, that's good. When we see a salt, when we see one particle of salt, it has a definite shape. Okay, so these are also solids. Now we will move on to the liquids. Now liquids have lesser force. We had just discussed this. Now they take shape of the container in which they are kept. Okay, take shape of container, and then they don't have fixed shape. Okay, so they don't have fixed shape, but these liquids have fixed volume. So what is the difference between a solid and a liquid? That a solid has fixed shape, but a liquid doesn't has a fixed shape. It takes the shape of the container. Okay, so the forces of attraction is lesser as compared to that in solids. So it has slight kinetic energy. The particles possess slight kinetic energy. I'll denote kinetic energy in this form. Okay, so it has slight kinetic energy. Now the question rises that and they can be slightly compressed. Okay, slightly compressed. And we were in that example where we mixed sugar in water, we were able to see that diffusion occurs in liquids. Like other matters can diffuse into liquids, and this happens because there is space between the particles of liquid. Okay, so I'll give you examples like diffusing of, if we take the example of diffusing solids into liquids, it is the mixing of sugar in water. Now we take an example of diffusing ink, like a liquid into liquid. We saw an example where we mixed red ink into water. Now when we see the example of diffusing gases into liquid, the oxygen gas and carbon dioxide gases are present in water, which is an example of diffusion of gases into the liquids. Okay, I hope it's clear. Now when we come to gases, gases have the least force of attraction. Okay, so as they have the least force of attraction, they also take shape of container, like in whatever container you keep them, they'll take its shape. So this means they don't have fixed shape. Now how they are different from liquid is that they don't even have a fixed volume. Okay, no fixed volume. So if we put them in a 10-liter container, the volume of gases will become 10 liter. They'll move around, they'll occupy the whole container, and if you put the same amount of gas in a container of 1 liter, then also they'll occupy 1 liter only. So the volume is also not fixed. The volume also changes. Okay, now when it comes to kinetic energy, the particles of gases are placed the farthest, so therefore they have the highest kinetic energy. Okay, so the gases that we are discussing, now when a matter is in gaseous form, it has the highest kinetic energy and it is highly compressible. As the particles are far away from each other, so we can apply force and bring them together. Therefore they are highly compressible. But when in the case of solids, they can't be compressed as the particles are already close to each other, so we cannot apply force and bring them closer. Okay, now when we are discussing diffusion, so gases have more space between them, so it is easier for us to diffuse these gases as compared to the other states of matter. Okay, so these are the few basic properties that we have discussed about all the three states of matter, and now we'll be also discussing these in a tabular form so that it is easy for you, and we'll be discussing different properties so that it is easy for you to comprehend it. But for now, if you have any doubts regarding this, you can ask your doubts. I'll clear your doubts, and then we'll see what we'll be doing next. Okay, so I'll wait for your doubts. Oh, please. Yeah, I guess I have doubts. Okay. I guess there are no doubts that we have, and there are no hands raised. So I think it is clear to everyone. So with this, I think we'll be ending today's class. You go through the notes that are present on the app till states of matter, and you can also find the video. We'll be uploading it later on YouTube, so you can go through the class again, and if you have any doubt anywhere, you can ask me in the next lecture. And the next class we'll be discussing the tabular form of the states of matter and the changes in the states of matter. These are the major topics that we will be discussing in the next class, and then later we'll be seeing the in-text questions of your book, and then we'll also see the exercise questions. So please go through the notes, and if you have any doubts you can ask. So now I'll be unmuting you all. Okay, so I have unmuted everybody. I hope you all understood everything in today's class. Okay, and if you have any doubts you can ask me. I'll clear your doubts. Any doubts?
Hello.
Hello, do we have any doubts? Anyone having any doubts? I guess there are no doubts. I hope everyone understood everything. So please study, stay safe, don't move out, and also enjoy with your family, study and be with them. Okay, so with this we'll end today's class. I hope you all understood every concept, and we'll meet in the next
Yes,
class.
sir.
Sir.
Okay, and we'll meet in the next class and continue this chapter. Okay,
Okay.
thank you.
Thank you.
Welcome, sir.
Hello.